Hi, how's it going? Here with Mr. Canada, and we're looking at estimating roots of positive numbers. So this method too only works for square roots, and requires that we know a little bit about perfect squares and a little bit about fractions. So what do? First step, we want to find this square root just smaller than our number. So we know that that is square root of 16, and that gives us 4. That will mean that will be our starting number. So our final answer will be 4 point something. We know from the last video we should have around 4.6-ish, right? If I remember correctly. So find the difference between the two. So the difference between 22 and 16, right? I don't really care about the root part. I just want the difference between the numbers, okay? Because if we could do the difference between those square roots, well, we'd probably find out what our actual answer is completely, right? So we know between 22 and 16, that is 6. So 22 minus 16 is equal to 6. So far that is our numerator. So I'm going to write this as 4 and 6 over, I don't know. Right? So this is what we're going to find. So double the smaller square from step 1. So 4 times 2 is 8. Right? So that's what I mean by the smaller square. It should say smaller square root. Right? Smaller square. No, like just the number, right? So here we're going to write it as now 4 and 6 over 8, which we can write as 4 and 3/4, which is 4.75. So pretty close. Let's look at the next one, square root of 45. So here our smaller square would be root 36, which is 6. So we know it's going to start with 6. Then the difference between 45 and 36 is 9. Okay, so that is our numerator. Then we have to double our original number, this 6. So we're going to get 12. And we're going to find that we have 6.75. So far, our estimates are working pretty good. They're actually working better for the larger numbers. So let's try this last one of estimating 214, because this one was a little bit harder with this big estimate, right? So we know that square root of 196 is our smaller square root, and that's 14. Okay, then 214 minus 196, that will give us 18. So we have 14 to 18 over, and well, what's double that? 14, that's 18 over 28, okay? So now we have to work out, well, what's 18 over 28? How can we simplify this, right? So I'm going to just see if I can't make it easier by writing it as 9 over 14. Right, so that doesn't really help us out too much, so we're going to have to actually do some long division, or short division. So how many times does 14 fit in to 90? Well, we know that it fits in 6 times, right? And then we're left over with 6. 6 times, we're left over with 6, because that makes it 84. We can't do anything, so we're going to have to add a 0. And 14 into 60, that is going to fit 4 times. And then we have 4 left over. Add a 0, and so it's going to go into 40 twice. Right, I'm just going to stop there, and I'm just going to say we only need it as an estimate, so 14.64 even. And once again, if we go back and check all these and compare with our last video, we'll see that they're relatively close, because I'm just going to do one of them because we've already gone through these answers once already. So 214 square root. So the actual value is 14.63. So that's remarkably close. So using this method, I want you to practice these questions. Some of them are the same, some of them are different. But I want you to know after which is more accurate, which is a better method, and which is a better method. Explain your reason, not why. Which is more accurate. Sorry. So you could say in any way, shape, or form. So pause the video. When you're ready, we will take up the answers. Alright, well, so welcome back. So we know the lower square root is 4. Difference between 16 and 19 is 3. And we double this 4 because 4 and 3/8. So that is 4.38 is, sorry, 0.375. We'll check it and see how close we are afterwards. Okay, so closest one square would be 7. Difference is 2. And our double our original is 14. So we have 7 and 1/7. 1/7 is about 0.14. So 7.14. Here the closest one is like 9 times 9, right? Is 81. So the difference is 5, and doubling this is 18. So 5 over 18 is 0.27 repeating, 9.27 repeating or recurring. Here, well, root of 169 is 13, so 144 is our closest, so we have 12. And then 168 minus 144 is 24. And then our then our lower number is going to be 24. So, 1 second. So you notice that this one actually is going to work out to, well, 13. But we know it's not 13, so we can just say, if I was doing this, I would say it's 12.9899, right? Just give something a little bit smaller. So it can happen with this method that kind of rounds up. So square root of 200, right? What can we do? Well, here we can say 196 is 14, right? Our difference then is 4. And if we double that, that's 28. So what exactly do we have? Well, we have 14 and 1/7. Well, we know 1/7 is about 1/4. And then this last one we can't do. It's a cube root. Put it on there to make you think, can we do this? So let us compare our actual values now. So get your calculator out and check if you haven't been already. I'll put the actual values right underneath. 3, 5, 9. 51 square root was 7.14. 86 square root was 9.27. Square root of 168. Sorry, 168 was 12.96. Square root of 200 is 14.14. So, now, which is more accurate? Well, this method is more accurate. Which is a better method? That's dependent. Are you trying to figure out square roots? Are you trying to figure out any other kind of root, right? So if it's square roots, I would say this method. If it's any other kind of root, we have to use trial and improvement. Otherwise, look at question 1. It is 2 hundredths off, right? 2, it's bang on. 3, it's bang on. 4, we had to kind of fails when it gets really small numbers and really and square roots that have the same fraction, which is just a rare case. And lastly, 5, really accurate for specifically for doing a square root of something 200 or larger. That is very accurate.